Hello everybody, Zachary Fruling, aka Cozy Azeroth here. I am working my way through a number of old TI Basic or TI Extended Basic type-in programs from computer magazines from the late 1970s all through the 1980s and the early 1990s. The program I'm going to type in today, I'm going to scroll down to the beginning of the program, is called Bounce. It's a Sprite demo program submitted to 99'er magazine by Mark Hom in Bethesda, Maryland. Let's go ahead and read the program description, then we'll get into Classic 99 and get into TI Extended Basic. We'll type the program in, run it, see what we can learn from it, and see what we can make it do. Okay, so here we go. Dear Sir, I am what one might call a cautious buyer. After comparing the TI 99'4A with other personal computers on the market, I was convinced that it offered the best programming features and versatility. Now, after 4 months of basic and extended basic programming, I am still convinced. What impressed me most was the graceful motion achieved by the use of sprites. I soon realized that if this motion could be mapped on the screen, intricate patterns could be drawn. However, I was limited by the low resolution of the 24 by 32 spacing of characters. This results in only 768 positions and choppy, discontinuous lines. In order to use the possible 49,408 pixels on the screen, I thought I would need assembly language to poke these positions. However, I worked around this problem in the following way. First, I divided the character space into a 64-pixel grid and assigned a character to each pixel. This was done by assigning each position an array coordinate and a corresponding ASCII number. Once this is done, the position of a sprite can be taken. The row and column of the point can be found from the integer value of the sprite coordinates divided by 8. The remainder decides where on that 64-pixel space the point should be placed. The result is high-resolution line drawing with minimal expenditure of memory and no need for assembly language. The example given in the following program maps the trajectory of a bouncing ball. One recommended set of inputs is 28, 2, and 8, actually 28.2 and 0.8, for the vertical velocity, horizontal velocity, and damping factor, respectively. Other graphic applications are numerous. For instance, detailed sine curves can be drawn even from console basic. Okay, let's get into TI Extended Basic in Classic 99. Classic 99, by the way, is an amazing emulator for the TI 99'4A. And let's get typing. 100, call clear. And I'm going to try to type this program exactly as written. And if we encounter any errors, we'll hopefully be able to fix them on the way. But I'm going to give the magazine the benefit of the doubt. Call CHAR 97, comma. Okay, I got to be a little careful with these hexadecimal strings. 3C, 7E, 7E. Okay, a lot of F's here. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 F's. And 7E, 3C. 7E, C3. Let's make sure I got that. 7E, 3C. Oh, nope, I got it backwards. 3C. 7E, 3C. Oh, kind of rhymed. It was easy to get wrong. 7E, 3C. 7E, 3C. Okay, got it. And is that the end of line 100? It is. 110. Display at 3,10. Display at 3,10. We've got colon, and we've got, okay, looks like quote, 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 bounce, exclamation mark, quote, quote, quote. Okay, 120. Display at 10,3. Hello everyone tuning in. I see a couple folks tuning in. We're just working on an old TI Extended Basic type-in program from 99'er magazine from, I think we said it was, what month was this? June 1983. That's what we're working on now. This is a program called Bounce. It's a Sprite demo and has something to do with leaving a trail behind Sprite. So we'll see how it looks. Okay, vertical velocity. I'm going to go really slow and steady here because I want to type this in exactly as written for posterity here. Vertical velocity looks good. 130. It's not that long of a program, only up to line 320, so it'll go fast. 130 display at 12,3. Horizontal speed. $140. How's everyone doing today? Anyone who's tuning in live, thanks for tuning in. Display at. Oops, sorry, I have to scroll down a little bit. There we go. 14,3. Damping factor. Okay, I don't know what that means yet. And quote. 150. Aw, hey my love. I love you too. I got off work early, not early because I put in a full work day already Uber driving and she's still stuck at work. Hi my love. That's wonderful. 21st century is magical, isn't it? Okay, 150. Except at 10,22. Let's see. Oop, nope. Beep. Not familiar with the syntax here. You know, I didn't grow up using Extended Basic. I didn't have the Extended Basic cartridge, so some of the quirks of Extended Basic still catch me by surprise. Okay, beep, and then P. Okay, we've got space, colon, space, except at 1221. Beep, and then SP, these must be the input variables here. Beep, SP, space, colon, except at 1419. Beep, and we're going to call that damp. Is that all for line 150? It is 160. Randomize. Colon. Randomize ensures you get a new randomization sequence every time the program is run. For t equals 1 to 12. For next loop. Call color. I don't know why anyone would write a program in Basic, Extended Basic or otherwise, on TI Basic or TI Extended Basic that doesn't use color. It's such a colorful computer. Okay, t, comma, integer of r in d times 13, r in d times 13 plus 3. Okay. Comma 1. Okay, we've got, I've noticed that magazines are a little loosey-goosey on the spaces before and after these double colons, and it doesn't really matter, and TI Extended Basic seems not to care. So I noticed no space there, so I'm going to type it exactly as written, faults and all. I think it'll still work. Next T, okay, colon, called Sprite. This is what actually draws a sprite onto the screen. Number 1, comma 97, comma 16, comma 158, comma 16, comma 0, comma 0. 16, comma 0, comma 0. I think that's all for line 160. Yep. Okay, we're going fast here. These next lines are going to go pretty quickly. 170, call clear. Colon, colon. Okay, dim D8, comma 8. Dim D8, comma 8. We have colon, colon, space. A equals 32. Colon, colon. Okay, B, comma F equals 0. I don't think it works like that in regular TI basic. It must mean is assigning the value of 0 to both B and F. B equals 0 and F equals 0. I think that's what's going on there. I'm not 100% sure. Okay, that looks good. And if we encounter any issues, we'll fix them when we try to run it. Okay, 180 for y equals 0 to 7. Y equals 0 to 7. Space, colon, colon. For x equals 0 to 7. Space, colon, colon. A equals a plus 1. Just incrementing the value of a. Okay, d of y comma x. D of y comma x equals a. Space, colon, colon, space. Next x. Next y. And a equals 32. That's all for line 180, I believe. Yes. 190. Okay, I'll scroll a little bit here. Not that far. Okay, 190 for w equals 3 to 0. W equals 3 to 0. And I saw a step value there. Step -1, so counting backwards by increments of -1. Colon, colon, space. Excuse me. To a equals a plus 1. Okay, call char, defining a character. A, comma, okay, rpt string, okay, 0, oops, 0, not an O, 0, oh, quote 0, quote 0, comma B, and str string, okay, be careful here, let's go slow, parentheses 2 to the power of w, two parens. We're done with that statement. Okay. Colon, colon. Next w. Space, colon, colon, space. b equals b plus 1. Space, colon, colon, space. If b is less than 16, then 190. And that is all for line 190, I believe. Looks good. Basically, it's going to force it to repeat line 190 till a certain condition is met. Okay, 200. For u equals 30 to 0, for u equals 30 to 0, step I wonder if it means negative 2. 30 to 0, step 2. I'm not sure about that. Let's keep that in mind in case we encounter any issues in the program. Call sound. Okay, negative 200, comma, 220 plus 7 times u, comma, u, colon, colon, next u. Yeah, that line 200 concerns me a little bit. Let's see. Okay, 210, P equals P times damp. P equals P times damp. Dampener level, I guess. If P is less than 2, then 290. P is less than, let's double check. If P is less than 2, then 290. Yeah, looks good. Okay, that's all for line 210. 220. For Z equals negative P to P, or Z equals negative P to P, colon, colon, call motion, changes the motion of the Sprite. Number 1, comma, Z, comma, SP. I tell you, I think people, I'm good at programming, but I think there are people who are really, really better at programming than I am. This is just creative stuff. .230, call position. Number 1, comma, R, comma, C. Number 1, comma, R, comma, C. Colon, colon, space. R1 equals integer of R divided by 8. Colon, colon, space. C1 equals integer of C divided by 8. I think that's all for line 230. Yep. 240. Y equals 8 times R divided by, okay, parentheses, R divided by 8 minus R1. R divided by 8 minus R1, more accurately. Just to emphasize the right thing there. R divided by 8 minus R1. That looks good. In paren, colon, colon, space, X equals 8 times looks like C divided by, is that B or is that 8? I'm a little concerned now. To me, it kind of looks like a B, doesn't it? Oh man, I'm really not 100% sure. To me, that kind of looks like a B instead of an A. Look at that, that sharp corner on the top left of that. Let's try it with 8, and if we get any weird behavior, we'll fix it. I'm not sure though. That's a tough one to eyeball. All right, 250. If C1 is greater than 31, then call locate. Number 1, comma, R, comma 8. But if you look here, same thing here. This got kind of, it's a bad scan. That's clearly an 8, but it looks kind of angular. I think those are 8s up here. I hope so anyway. So if you look at a B, there's a B somewhere. Looks a little different. I still think that's an 8. Okay, so 250. Colon. Go to 230. If C1 is greater than 31, then call locate and then go to line 230. Okay. Oops, 260. Well, these typing programs are always a little slow going. A 260, call HCHAR. R1 plus 1, comma, C1 plus 1. Hi, Dinah. Dinah, say hi. Girl, Dinah. And then D of Y comma X, and paren, and paren. That's line 260, 270. Next Z. Colon. F equals F plus 2. Yeah, they're doing yard work outside. Oh, Dinah. Dinah doesn't like yard work outside, I don't think. Okay, F equals F plus 2, space, colon, space. If F is greater than 28, F is greater than 28, then F equals 28. Call sound. Two, 220, F. Colon, space. Go to 210. Call motion. Number 1, 0, SP. Number 1, 0, SP. That's all for 290. Yep, short and sweet. 300. For A1 equals 1 to 9. For A1 equals 1 to 9. space, colon, colon, space, call color, A1, comma, integer, R in D times 13 plus 3, R in D times 13 plus 3, comma 1, okay, colon, colon, space, call key, 0, comma k, comma st, 0, comma k, comma st, colon, colon, space, if st, it's a Boolean variable, if st, then call clear, space, colon, colon, space, call car set, character set, colon, colon, go to 100. It looks pretty good. 310. Next A1. Or is it A1 or is it AI? Ask Linda McMahon. Next A1 space. Go to 300. And 320 end. Okay. We're going to type call clear to clear the screen, list out the program. And it's hard to, you know, visually see if there are any errors. I'm looking for anything obvious and glaring, you know, typos, syntax errors, math errors, that kind of thing. So we have two potential problems we identified. One in line 200. So this might be, should be 30 to 0, step -2 perhaps, maybe. And also a potential problem in line, what was it? It was line number, where are you? 240. It could be that those need to be B's instead of 8's, but I'm not sure. Let's go ahead and clear the screen. Again, we'll run the program and see what we get. Do we get behavior as intended? Okay, so the book suggest, or the article suggests a couple of specific variables here. Okay. Okay, one recommended set of inputs is, I think that's supposed to be a comma, not 28.2. 28, comma, 2, and 0.8 for the vertical velocity, horizontal velocity, and dampening factor. Okay, yeah, it's 3 variables. Okay, 28. And then we have 2. And then we have 0.8. Let's get a screenshot here. And let's see if that does the trick. Okay, what's happening? Okay. Oh, there. Oh, yep. Bad subscript in list 260. Let's see. Okay, let's check out line 260. Call HCHAR. That looks good. R1, comma 1. That looks good. C1, or excuse me, R1 plus 1. C1 plus 1. And D, Y, comma X, and parens. Okay, it's supposed to be X, comma Y? Maybe? No, D, Y, comma X. What does bad subscript mean? Bad subscript. Let's see if we can figure this out. I hope we can get to the bottom of this. I didn't write the program, so. Bad subscript. What does that mean? Call HCHAR, R1 plus 1, C1 plus 1, D. Y comma X. I don't see any errors. Bad subscript. It could be that's supposed to be, maybe the problem is in 240 because Y and X are being pulled in from line 240. So let's try our hypothesis here. 240, Y equals 8 times R divided by B minus R1. And X equals 8 times oh wait oh I think I see the problem actually. Hold on, this is supposed to, let's try it. Let's leave it 8. I realize I typed something in incorrectly. Okay, 240. X equals 8 times R divided by 8 oh no, excuse me, I see what I did. C divided by 8 minus C1. Okay, yep, I had a typo in there. So let's try just fixing the obvious typo and see if that fixes the problem. Sorry about that. It happens. At least you're getting some real-time debugging of an extended basic program. So let's 240. Let's make sure we got that right. Okay. Let's list out the whole program now. Okay, let's run it and see what we get. So we're going to use the same values, which suggested values, which are 28, 2, and 0.8. 28, 2, and 0.8. I'm sure I got those right. 28, 2, and 0.8. Yes. Okay, it's going to take a minute. I think it's doing stuff with the array. So in a minute it should start moving. Yeah, there we go. Okay, it's working. Oh yeah, look. Check that out. Oh, cool. That's neat. I like this program. This is cool. I like that the colors are just very cute and rotating. The color of the trails. Okay, how do we get it to end though? Okay, call key 0, K, ST. Okay, I don't know how to make. There we go. Okay, vertical velocity. Let's see. I don't know, how about 35? Horizontal speed. let's see, was originally 2. Let's do 1.3 and damping factor 0.7. Okay, let's see what we end up with here. There's no real frame of reference here. I got to just play with the numbers in relation to the last run of the program. Oh, bad value in 260. What's 260? Could be that it just can't go off screen. I think that's right. So we got to be, you have to use these values within a tolerance range, I think. So let's run it. Be nice to have some input limiting to rein this in a little bit. So vertical velocity. So we had originally 28. Let's try, I don't know, 18. Horizontal speed, 1.1. Damping factor, I still like 0.7. So let's try that. Shouldn't go quite as high up, I think, this time. I like this program a lot. This is fun. And it's just going to roll until we start it over. Okay. Vertical velocity. 28 was pretty good. That gets you up to the top of the screen. Horizontal speed. Let's really make this move. So we originally had 2. Let's do 4. Damping factor 0.6. Not exactly sure what the damping factor does. It's one of these programs you could play with all day and make it do cool stuff. In the video description, I'll post a link to the article in case you want to type this one in and give it a run. That was cute. Yeah, this ball will just kind of keep trucking along until we end the program. Or hit K. I've been hitting K to start a new version of it. Got a screenshot there. That's cool. Okay. I want to make it go a little higher, though. Vertical velocity. Let's do 20. How high can we push this? 29. Horizontal speed 5. Damping factor. Let's just do 1. Oh, excuse me. I got a pop-up notification here. Okay. Nope. Thought I had another Uber reserve ride. Okay. That should be cool again. Hopefully 29 isn't too high. I lower the or increase the damping factor. I think that I'm worried that it might go off the screen and get an error again. We'll give it a try. Yeah, that's too high. Okay, run. So we've got to do 28 horizontal speed. Let's really make this move along. Let's do 7. And same thing for the damping factor. It was 0.8, I think, right? Yeah, 0.8. I just don't want it to fly off the screen vertically. This should make it so it's moving horizontally to the right pretty quickly, but not go off the screen vertically and cause an error. That's a fun little program. I like this one. Yeah, here we go. Kind of a fun way to make cool graphics, isn't it? I like it. These are cool designs. I could really play this one play with this one all day. I'm gonna make sure I save this one. It's working as expected. So we did manage to. I fixed my own typo, but it was there were no errors in the program, thankfully. So I was worried about it, but. Yeah, very cool. I like this one. Well, there you go, everyone. That was Bounce, a Sprite demo program by Mark Hom from Bethesda, Maryland. And this was in 99'er magazine, volume 2, number 8, which was June of 1983. Like I said, I'm going to post a link to this article in the video descriptions on YouTube down below. So if you're checking this out on YouTube, be sure to check out the video description. I'll also, there's a popular TI-99 for a Discord server. I'm going to post the program file in there once I save the program file, which I'm going to do right now before I forget. Let's do that. So save, I've been saving things to DSK2, and we're going to call this Bounce. Okay, let's make sure that worked. Hold DSK2.bounce. Yep, there we go. I'm going to run it one more time before I end the video here. It's just so cool. Make it do something cooler even. Okay, run. So I think we found the sweet spot. In case you want to try this yourself, the sweet spot here seems to be 28. Horizontal speed, you can do whatever you want. Let's really bump this up. Let's bump this up to like 14. And damping factor 0.8 seems to be about right. Okay. So while this is running, it takes a minute for it to start running because it's got to do some stuff with the array, I believe, is what's happening. That's causing the delay there. Let's see what it does real quick, and then we'll let it run for a minute. Okay, there we go. All right, go Sprite, go! It's really cool. It's a cool way of drawing a sine curve too. You know, I can imagine a program, a trigonometric program that makes some really cool trig function graphs. Well, in any case, if you happen to be watching this after the fact on my YouTube channel, be sure to check out the rest of my YouTube channel. You can find it under my real name, Zachary Fruling, or under my Twitch handle, Cozy Azeroth, for lots more TI-99 4A content, retro programming, retro gaming, some World of Warcraft live streaming, and miscellaneous educational videos on a wide variety of topics of interest to me, both professionally and personally. And if you happen to be watching this live on Twitch, hello, be sure to say hi in the chat, and feel free to participate in any way you see fit. And in any case, I appreciate likes and follows and especially subscriptions, which help me out greatly in these challenging and troubling financial times. Thank you very much, and I'll catch you in the next video with more TI-99 4A, TI Basic, and or TI Extended Basic type-in programs. Thank you much. I'll catch you in the next video.